Good question. Is this inches or millimeters? 0.001 inches. Now there's three levels we have to read here. The big dial is the last level. The first level is positive or negative. This arrow is not really there. It's just showing us that the needle from 0 moved that direction. So this is negative. It's going in the negative direction. Next we have this small dial, which is the tenths place. You can see here it's 0.1. It's between 0 and 0.1, which means it is 0.0. Now, since it goes this way, the dial reads that way. So 10, 20, 30, 40, 50, 1, 2, 3, 4, 5, 6. So 0.056 inches. You had sort of the right idea. So I'm going to give you a minute to read this one. So it's negative again. So this, remember, is millimeters. So this is actually 1, 2. It's a whole 2.58. Had the right idea.
My God. You just had it.
Here, we'll give you one to try here. Millimeters or inches? Millimeters. Positive or negative? Positive. Down here, that is a 1. Since it's millimeters, that is in front of the decimal point. And since it's positive, this is 50, 60, 70, 1, 2, 3, 4. Positive or negative? Negative. Zero is on the little dial. So this will be 1029. This one, positive or negative? Negative. Whole number? Trick question, 0, because it's now in inches. So this is 0.1, 59, right? Inches. Let's try this one. Positive or negative? Positive. And it's 0 because it's in inches. Point between 4 and 5, so it's going to be 0.4. 37. This is usually a surface meter, so they can actually go out or in. You set them so that it's 0, and either you can slide them across the surface, or they can, if you have something that needs to stay stationary, you put it on there and it'll measure how far it's warped in or out over time. They're actually very common in the industry. Probably. I wouldn't recommend buying calipers or micrometers at Farm and Fleet. Somebody bought a caliper and they brought it in and I looked at it. I was like, holy crap. I mean, the scale was so weird on it. It was.
I seen one of them, what do you call it?
Vernier, yeah.
Yeah, vernier caliper thing.
At Farm and Fleet?
Mm-hmm.
Yeah, the one that I've seen the one that they have there, and it is extremely difficult to read because it doesn't read anything like the ones we have.
Must have been that one.
Because all the ones they have there are dual unit. They have both standard and metric units on the same caliper.
Oh.
That makes them really tough to read. Okay. They also had a 64th inch caliper there too. It was all on the same dial with the decimal inch and the millimeter on. So there's 3 different numbers on the same dial. That was fun. Okay, so what we're going to look at today for new material, we're going to look at something like this. X equals 7. Of course, it's called an equation. And the key to it is this thing right here, which is the equal sign. What does it mean? It's kind of hard to define it without using the word equals, isn't it?
X is same.
Okay. Yeah, what it means is what's on one side is exactly the same or has exactly the same value as what's on the other side. In fact, you could actually think of it as being a balanced scale, where what's on one side exactly balances what's on the other side. All equations start out in this form as a variable equals a number, and they're built up from there. So from this simplest form, there are some things we could do to build up. We could add, subtract, multiply, divide, powers, roots. Any of our operations that we have learned can be done to an equation to build it up, to make it more complex. So let's try to add. Let's say we're going to add 5. So this is now x plus 5 here. Now if I add 5 over here, this scale is going to tip unless I do what? Add 5 to the other side. I have to do the exact same thing to both sides in order to keep that scale balanced. So now we've built this equation. We've built a more complex equation from that original one. Now in this class, we're generally not going to be building equations so much as we're going to be solving equations. So when you're given the command to solve, what it's asking you to do is to take this equation back apart and put it into this form again. Well, this equation was built by adding 5, so how do we take it apart? Subtract 5. Takes that away, we're left with x. Now because of that balanced scale thing, if I subtract 5 from one side, it's going to tip unless I do the exact same thing to the other side. So I subtract 5 from the other side, 12 minus 5 is 7. And there we are. We're right back to where we started. Now this one here, we built it. So we knew how it was built, so we knew how to take it apart. The trick is looking at these and figuring out how they were built so you can figure out how to take them apart. So let's look at one like this. To figure out how to take them apart, we first find the equal sign. Come on. Right there. Then we identify which side of the equal sign the variable's on. It's over there. Then we ask ourselves, what is keeping our variable from being by itself, from being alone? In this case, it's the 3. What operation is used to build that 3 onto the variable? It was subtracted. So to take this equation was built by subtracting 3. So to take it apart, we're going to add 3. So 2 plus 3 makes 5 over here. On this side, the minus 3 and plus 3 cancel out, leaving me with y. So 5 equals y. Now, if you're unsure of yourself and don't know if you did it right, you can always take this value here and put it back in for y in the original equation. Y minus 3 will become 5 times 3, which equals 2. So we do get the same value on each side of the equation. So we might have 7z equals 21. So again, we find the equal sign. We identify the side as the variable on it. What's keeping the z from being alone? 7. What operation was used to build the 7 onto the z? It was multiplied. So to get rid of it, we're going to divide. Divide by 7 and make sure we do the same thing to both sides. Keep it balanced. Z equals 21 divided by 7 is 3. Any questions so far? Well, my screen just froze up on me. It'll scroll, but she won't click. Okay, so now we can run into equations like this. So for this one, just like before, we find the equal sign right there. We identify which side is the variable, which is over here. But now there are two things that keep that variable from being by itself. The 3 has been multiplied and the 2 has been subtracted. Now, according to order of operations, if we look at how this equation was built, what was done to my variable, what was done to x to build this equation? What would happen first? Would we multiply by 3 or would we subtract the 2 first? Order of operations says we would multiply first, right? So this equation was built. The first thing that was done is x was multiplied by 3, then the 2 was subtracted from it. Now, if you think about putting together something, if you put together a piece of furniture or a kit of some sort or whatever you're putting together, and you've just finished, you just put on that last piece. If you have to take it apart again, what's going to be the first piece that comes off? The last piece you put on. So it's the same with the equation. The last piece put on was the subtracting 2. That's the first piece we're going to take off. So we're going to take it off by adding 2. That's gone, leaving us with 3x. Now we have to remember, because this is at balanced scale, whatever happens to one side, we have to do to the other. So I have to add 2 over here. 34 plus 2 is 36. Then what? Divide by 3. X equals 12. And just like before, if we want to double check, we can always go back and replace the variable here with that number. So 3x can become 3 times 12 minus 2. And let's check to see if that equals 34. 3 times 12 is 36. Minus 2 does give us 34. So we do get the same value on each side of the equation. Well, if you try that one in your notes quick, see what you come up with. So that's the first thing we have to do. Subtract 7. So we got 35 equals 5x. Perfect. We divide by 5. 7 equals x. We can try it back out in here. I took the 7 and put it back in where the x was. 5 times 7 is 35, plus 7 is 42. So it's the same value on each side. What's different about this one? Yeah. I find the equal sign, we look to where the variable is, and we see that x appears twice on this side of the equation. Now, when we think of that balanced scale, the 5x and the 2x are both on the same side of the scale. So does that mean we can just take them, push them into one big pile? Would that change the balance of our scale? No, they're on the same side, so we just push them together. 5x and 2x, we can make it into 7x. We haven't changed anything in the way this scale balances. We can just combine those. And now it looks just like what we've done before. Subtract 7. 7x equals 28. And then divide by 7. X equals 4. And just like we've done before, we can put the 4 back in where the x is. So 5x becomes 5 times 4. Plus 7 plus 2x becomes 2 times 4. Equals 35. 5 times 4 is 20. Plus 7 plus 2 times 4 is 8. Equals 35. We add those together, we do get 35. So same answer, same value on both sides of the equal sign. Well, if you guys try one. Try that one in your notes. Where to start? Should combine the x's first. They're on the same side though, so I can just combine them. 3x and 2x do make 5x. And now we would add the 4. So 5x equals 40, and then divide by 5, you get x equals 8. Any questions? What's different about this one? Yeah, the x still appears twice, but one's on each side. There's one over here and one over here. I cannot just push them together anymore because they're on different sides of the scale, different sides of the equation. What I have to do is just get rid of one. Literally take it away and get it out of there. Mathematically, the way I do that is subtract it. Or if it's negative, I can add it. The first part is to figure out which one I want to get rid of, and generally I get rid of the smaller one. So 3x is the smaller one, so I'm going to subtract 3x and it'll be gone. That leaves me with 5 here. But as always, I have to do the exact same thing to both sides. I have to take 3x away from the other side. The only place I can take that away from is the 6x. So 6x minus 3x is 3x. Minus 22 then is still sitting there. And now it's just like our other equations. What do we do next? We add 22. So 27 equals 3x. And then divide by 3. You got it. So 9 equals x. And as always, you can go back and put that back in there. Replace each of the x's with 9. So 3 times 9 plus 5, does that equal 6 times 9 minus 22? 3 times 9 is 27, plus 5 is 32. 6 times 9 is 54, minus 22 is 32. We get the same value on each side of the equation. So whenever you guys try, try that one quick. So start by getting rid of one of the x's. Which one are we going to get rid of? Smaller one is the 3, so we subtract 3x. So we have 4x plus 4. Over here, all that's left is the positive 28. Subtract 4. So 4x equals 24, and then divide by 4. X equals 6. Any questions? Okay, well, they can get a little bit more complex yet. It can look like this. Of course, the thing that's obviously different here is the parentheses. And whenever you see parentheses, it should scream at you, do something here first. In this equation, well, there's 2 questions you have to ask. The first is there anything I can do inside the parentheses? And there isn't. I can't. 5x plus, and then 5x and negative 7 cannot be combined. So the next question is there anything that needs to be done to the parentheses? And that is the times 3. So 3 times 5x is 15x, and 3 times negative 7, negative 21. That equals 9. And now it's just like what we've done before. What do we do next? We add 21. So 15x equals 30, and then divide by 15. X equals 2. And just like any others, we can put 2 in where the x was. So 3 times, instead of 5x, it's 5 times 2 minus 7 equals 9. So 5 times, now notice I'm not distributing here because I can't, once I put a number in for x, I can do what's inside the parentheses. So 5 times 10 is, or 5 times 2 is 10. 10 minus 7 is 3. 3 times 3 is 9. So 9 equals 9, that's true. I get the same value on each side of the equation. And have you guys try one? Give that one a shot quick. Start. Yeah. And we do have to check. There's nothing we can do inside the parentheses. So we will distribute the 5. 5 times 3x is 15x. 5 times 2 plus 10. Subtract the 10. So 70 minus 10 is 60 equals 15x. We'll divide by 15. So 4 equals x. Okay. Anybody have any questions? I'm going to let you guys try some of these then for homework quick for the first hour. In your book, page 249, exercise 6.1, 1 through 59, the odds. Those are pretty simple ones. Again, as always, feel free to do the first couple and skip ahead. Page 251, exercise 6.2, 1 through 29, the odds. Those will be a little bit more complicated. Okay, I'll give you about 15 or 20 minutes to work on those, and we'll take a break, and we'll start the second half of class.